Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataong maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan po bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Good morning, senior high school students of Valenzuela City. Welcome to Valenzuela Live Facebook live streaming in General Mathematics. I am happy to be with you once more. Come and join me as we venture into today's learning experience. Are you ready? Let's start! We are now on quarter 1, week 5, which is about inverse functions and exponential functions. At the end of this session, you are expected to meet the following most essential learning competencies. First, solve problems involving inverse functions. Second, represent real-life situations using exponential functions. And third, distinguish among exponential function, exponential equation, and exponential inequality. Let us start today's lesson by answering our first activity entitled, Who am I? I am a non-negative even number. Subtracting 4 from me, multiplying the result by 5, and dividing the product by 2 will make me 40. Who am I? I am a non-negative even number. Subtracting 4 from me, multiplying the result by 5, and dividing the product by 2 will make me 40. Who am I? I will give you 30 seconds to key in your answer on the comment box. Time's up. If you answered 20, then you are correct. How did you get your answer? It is not surprising that you just guessed the answer, because trial and error is one of the different techniques in answering a problem like this. Let us check your answer. From the problem, it is good to start with 2, since it is a non-negative even number. However, it will not give us an answer of 40. So, with this method, we will keep on trying until we reach a number that will satisfy the given condition, which is 20. That is, 20 minus 4 times 5 divided by 2, is that equal to 40? Perform the operation. 20 minus 4 is 16. Then copy times 5 divided by 2, is that equal to 40? But 16 times 5 is 80. So, we have 80 divided by 2. Is that equal to 40? Last, get the quotient of 80 and 2, which is 40. So, 20 is the correct answer. Another technique that you may have used is working backwards. From its name, we start answering from the end, performing the inverse of the given operations until we reach the beginning of the problem. That is 40 times 2 instead of dividing by 2. Divided by 5 instead of multiplying by 5. Adding 4 instead of subtracting 4. Next, perform the operation. That is 40 times 2 is 80. Copy the remaining expression divided by 5 plus 4. Divide 80 and 5, which will give us 16, and copy plus 4. Last, add 16 and 4, which will give us the answer of 20. But this problem can be solved using inverse function. First, represent the given problem as a function of x, where x is the number that we are looking for. That is, f of x is equal to the quantity x minus 4 times 5 divided by 2, which is similar to y is equal to 5 times the quantity x minus 4 divided by 2. Next, interchange x and y. We have x is equal to 5 times the quantity y minus 4 divided by 2, and solve for y. Look at the expression. What do you think is the first step to solve for the value of y? You're right. Multiply both sides by 2 over 5. The 2 over 5 and 5 over 2 will give us an answer of 1. And 2 over 5 multiplied by x will give an answer of 2 over 5x. So we have 2 over 5x is equal to y minus 4. Remember that we are solving for y. So what's next? Correct. Add 4 to both sides and it will give an answer of 2 over 5x plus 4 is equal to y, which is similar to f inverse of x is equal to 2 over 5x plus 4. Now that we get the inverse function, let us substitute 40. We have f inverse of 40 is equal to 2 over 5 times 40 plus 4. But 2 over 5 of 40 is 16. So we have 16 plus 4. Last, add 16 and 4. So we have f inverse of 40 is equal to 20 as the final answer. Let us now move on our next example. It is known that the maximum force T in tons that a certain bridge can hold is related to the distance d in meters between its supports by the function T of d is equal to the quantity 12.5 over d raised to 3. How far should the supports be if the bridge is to support 8 tons? Construct an inverse function to determine the result. For the solution, use the given function t is equal to the quantity 12.5 over d raised to 3 and solve for d. To solve for d, first get the cube root of each side of the equation. And we will get cube root of t is equal to 12.5 over d. Next, multiply both sides by d over cube root of t. Dividing d in the numerator and d in the denominator in the right side of our equation will give us an answer of 1. Dividing cube root of t in the numerator and cube root of t in the denominator in the left side of our equation will also give us an answer of 1. Then, we will have cube root of t is equal to 12.5 over d, which is similar to d of t is equal to 12.5 over the cube root of t. From here, let us evaluate the function at t is equal to 8. That is, d of t is equal to 12.5 over the cube root of t. Becomes d of 8 is equal to 12.5 over cube root of 8. Performing the operation, we have d of 8 is equal to 12.5 over 2. Divide 12.5 by 2 results to d of 8 is equal to 6.25. Thus, the supports should be placed at most 6.25 meters apart. Can you follow grade 11? Very good. Moving on to our next lesson, we have exponential functions. An exponential function with base b is a function of the form f of x is equal to b raised to x, or y is equal to b raised to x, where b is greater than 0 and b is not equal to 1. First example of exponential functions is f of x is equal to 6 raised to x. It is in the form f of x is equal to b raised to x, where 6 is the value of b, and it is greater than 0 and not equal to 1. Another example of exponential functions is y is equal to 2 raised to x minus 3. It is in the form y is equal to b raised to x, where 2 is the value of b, and it is greater than 0 and not equal to 1. Our next examples are not exponential functions. F of x is equal to x raised to 2 and y is equal to 6x. Notice that exponents are not expressed in variable, and b cannot be determined if greater than 0 and not equal to 1. Let us have this example. If f of x is equal to 4 raised to x, evaluate f of 3, f of negative 3, f of 1 over 3, and f of 0.2. For letter A, given that f of x is equal to 4 raised to x, substitute 3 from the given. We have f of 3 is equal to 4 raised to 3. 4 raised to 3 means 4 times 4 times 4, which is equivalent to f of 3 is equal to 64. For letter B, substitute negative 3 from x. We have f of negative 3 is equal to 4 raised to negative 3. By loss of exponents, this is equivalent to 1 over 4 raised to 3, where 4 raised to 3 is 64. So, f of negative 3 is equal to 1 over 64. For letter C, again, given that f of x is equal to 4 raised to x, substitute 1 over 3 from x. We have f of 1 over 3 is equal to 4 raised to 1 over 3. The expression 4 raised to 1 over 3 is same as the cube root of 4. So this can also be written as f of 1 over 3 is equal to the cube root of 4. For letter D, substitute 0.2 from x, and we have f of 0.2 is equal to 4 raised to 0.2. The decimal of 0.2 is 2 over 10 in fraction. So we have 4 raised to 2 over 10. What is the lowest term of 2 over 10? Very good, 1 over 5. So we have f of 0.2 is equal to 4 raised to 1 over 5. The expression 4 raised to 1 over 5 is equivalent to 5th root of 4. So this can also be written as f of 0.2 is equal to the 5th root of 4. Did you get it, grade 11? Nice! Let us have another definition about exponential function. Let b be a positive number not equal to 1. A transformation of an exponential function with base b is a function of the form g of x is equal to a times b raised to x minus c plus d, where a, c, and d are real numbers. Let us have examples to illustrate this in real life. At t is equal to 0, there were initially 15 bacteria. Suppose that the bacteria double every 20 hours. Give an exponential model for the bacteria as a function of t. Let us construct a table for the given problem, where time denoted by t in hours and number of bacteria reflected as title for our table. The number of bacteria will be written in 3 different ways, namely expanded form, exponential form, and in terms of t. Okay, let us start working on our table. From the problem, initially, there were 15 bacteria in expanded form, and 15 times 2 raised to 0 in exponential form. 2 raised to 0 since the number of bacteria is not yet doubled. Next, after 20 hours, it doubles, which is equivalent to 15 times 2 in expanded form, and 15 times 2 raised to 1 in exponential form. Raised to 1 since 2 appears once. Then, another 20 hours means adding 20 from previous number of hours, which is equal to 40. The bacteria doubled, that is 15 times 2 times 2. In exponential form, that is 15 times 2 raised to 2. Raised to 2 since the base 2 appears twice. Next, another 20 R's means adding 20 from the previous number of R's, which is equal to 60. The bacteria doubled, that is 15 times 2 times 2 times 2. The number of bacteria now is equivalent to 15 times 2 raised to 3. Raised to 3 since the base 2 appears thrice. Last, add 20 from the previous number of R's, which will give us 80. Here, the number of bacteria is equal to 15 times 2 times 2 times 2 times 2, which is same as 15 times 2 raised to 4. Raised to 4 since the base 2 appears 4 times. Now, let us fill in the number of bacteria in terms of T by observing the exponents on the third column. How could we get the exponents 0, 1, 2, 3, and 4, considering our time as 0, 20, 40, 60, and 80? Great! By simply dividing the number of R's in the first column by 20. That is, to get 15, we rewrite it as 15 times 2 raised to the quotient of 0 and 20. Since 0 over 20 is 0, then 2 raised to 0 is 1. Then multiplying by 15 will give us an answer of 15. We will do the same on the succeeding examples. That is, to rewrite 15 times 2 raised to 1, exponent should be 20 over 20. To rewrite 15 times 2 raised to 2, exponent should be 40 over 20. To rewrite 15 times 2 raised to 3, exponent should be 60 over 20. And last, to rewrite 15 times 2 raised to 4, exponent should be 80 over 20. If this will continue, what could be the exponential model of number of bacteria given the number of times it will double? If your answer is f of t is equal to 15 times 2 raised to the quotient of t and 20, you are correct. The exponential model for the bacteria as a function of t is f of t is equal to 15 times 2 raised to t over 20. Let us have our next example. Suppose that the half-life of a certain radioactive substance is 5 days and there are 100 grams initially. Give an exponential model for remaining substance. Solving this problem is somewhat similar on the previous problem. That is, we use table to represent the number of days denoted by T and amount of substance. The amount of substance will be written in 3 forms, namely expanded form, exponential form, and in terms of T. Okay, let us start answering. From the problem, where initially that is T is 0, there were 100 grams in expanded form and 100 times 1/2 raised to 0 in exponential form since the half-life of amount of substance has not taken place yet. After 5 days, the half-life, which represents 1/2, is 100 times 1/2 in expanded form and 100 times 1/2 raised to 1 in exponential form. Another 5 days, which makes T equal to 10. The amount of remaining substance will be 100 times 1/2 times 1/2, which is similar to 100 times 1/2 raised to 2. Add another 5 days will make it 15. The amount of remaining substance for this day is 100 times 1/2 times 1/2 times 1/2. And this again is equivalent to 100 times 1/2 raised to 3. Now, let us fill in the amount of remaining substance in terms of T by observing the exponents on the third column. How could we get the exponents 0, 1, 2, and 3, considering our time as 0, 5, 10, and 15? Good job! By simply dividing the number of days in the first column by 5. That is, to get 100, we will write it as 100 times 1/2 raised to the quotient of 0 and 5. Since 0 over 5 is 0, then 1/2 raised to 0 is 1. Then multiplying by 100 will give us an answer of 100. We will do the same on the succeeding examples. That is, to rewrite 100 times 1/2 raised to 1, the exponent should be 5 over 5. To rewrite 100 times 1/2 raised to 2, the exponent should be 10 over 5. To rewrite 100 times 1/2 raised to 3, the exponent should be 15 over 5. If this will continue, what could be the exponential model of the amount of remaining substance given the number of days of its half-life? If your answer is f of t is equal to 100 times 1/2 raised to the quotient of t and 5, you are correct. The exponential model for remaining substance is f of t is equal to 100 times 1/2 raised to t over 5. Let us have our last example. Mrs. Mariano invested 100,000 pesos in a company that offers 3% interest compounded annually. Make an exponential model for this situation. Same as the previous examples, to answer this problem, constructing table would be of big help. That is, time in years and total amount can be seen in our table. The time that Mrs. Mariano invested money makes t equal to 0. The money that she invested is called principal. After a year, the money that she initially invested, denoted by p, will earn interest. And that interest is computed by multiplying the principal by the rate of interest, which is denoted by p times r or pr. The p plus pr is equivalent to its factored form, that is, p is the common factor, and the other factor is p divided by p is 1, and pr divided by p is r. So we have p times the quantity 1 plus r as the amount of money after a year. After another year, so the time now is 2. Since the problem is compounded, the total amount in the previous year became the principal for the current year. That is, p times quantity 1 plus r is the new principal for this year. To get the total amount for this year, we add the principal times rate to p times the quantity 1 plus r. So we have p times the quantity 1 plus r plus pr. But the principal that we are referring to for this year is the total amount of the previous year. So, we rename p as p times the quantity 1 plus r. So, we have p times quantity 1 plus r plus p times quantity 1 plus r times r as the total amount for this year. We simplify it by getting its common factor, which is p times quantity 1 plus r, and the other factor as 1 plus r. But this is equivalent to p times the quantity 1 plus r raised to 2. So for the second year, the total amount is p times the quantity 1 plus r raised to 2. If this will continue, how could we model this exponentially? Observe now the total amount and the time in year. Can you see a pattern? Very good. The expression p times quantity 1 plus r is fixed, and the exponent is the time reflected on our first column. So, f of t is equal to p times the quantity 1 plus r raised to t is the exponential model for this. So, to get the exponential model for our problem, we substitute the given value of principal and rate of interest. Therefore, the exponential model for this situation is f of t is equal to 100,000 times the quantity 1 plus 0.03 raised to t. Remember that good observation from the given will help us model exponentially our problem with ease. Let us have a quick check of your understanding on representing real-life situation using exponential functions with our second activity entitled The Real One. I will present a real-life situation, and you need to determine which exponential function correctly represents the given. 5 seconds will be given for you to comment the real answer in the comment section. Are you ready? So here is the first problem. In 2020, the city of Valenzuela had a population of 714,978. For the past 5 years, the population is known to increase at an average rate of 3%. Which exponential function models this situation? A. P of t is equal to 714,978 times the quantity 0.03 raised to t. B. P of t is equal to 714,978 times the quantity 1.03 raised to t. 5 seconds, go. Time's up. The real answer is letter B. Let us move to our second example, or second question. The cell phone you bought last year, which costs 15,000 pesos, continues to depreciate at the rate of 20% each year. Which of the following models the amount of your cell phone in t years? A. A of t is equal to 15,000 times the quantity 0.8 raised to t. Or B. A of t is equal to 15,000 times the quantity 1.20 raised to t. You've got 5 seconds. Go. Time's up. The real answer is letter A. Did you get a perfect score? That's awesome. Moving on to our next topic, your skill in observation is a great help. Given the table, can you comment on some of your observations on each column? I will give you 30 seconds to drop your answer on the comment box. Time's up. Let us verify your answer. On the first column, you may observe that the exponent is a variable. The base is greater than 0, and the mathematical symbol of equal sign is present. On the second column, you may observe it contains expressions containing variable exponents and mathematical symbol of equal sign is present. On the third column, you may observe that exponent is also a variable, and mathematical symbols of inequalities are present. The first column are examples of exponential functions. The second column are examples of exponential equations. And the third column are examples of exponential inequalities. Before we formally define exponential function, exponential equation, and exponential inequality, let us define first exponential expression. An exponential expression is an expression of the form a times b raised to x minus c plus d, where b is greater than 0 and b is not equal to 1. Examples are 2 raised to x, quantity 1 over 3 raised to x minus 1. 2 and 1 over 3 are bases and are greater than 0 but not equal to 1. Also, exponents are of the form x minus c. To distinguish an exponential function is a function of the form f of x is equal to b raised to x, where b is not equal to 0 and b is not equal to 1. Examples are f of x is equal to 2 raised to x, g of x is equal to 1/2 raised to x, y is equal to negative times the quantity 5 raised to x. The three examples are of the form f of x is equal to b raised to x. Also, 2, 1/2, and 5 are bases and are greater than 0 but not equal to 1. Next, an exponential equation. It is an equation involving exponential expressions. Examples are 8 raised to 2x is equal to 8 raised to x minus 1. 5 times the quantity 2 raised to x plus 1 is equal to 160. And 6 raised to x plus 3 is equal to 36. Here, each of the expressions is an exponential expression. Last, an exponential inequality. Exponential inequality is an inequality involving exponential expressions. Examples are 5 is greater than or equal to 1 over 5 raised to x. 3 raised to x minus 3 raised to x plus 1 is less than or equal to 0. And 2 raised to x plus 3 is greater than 128. To test your understanding in exponential function, exponential equation, and exponential inequality, let us proceed to our last activity entitled Match Me. There will be two columns. Simply match the given exponential function, exponential equation, and exponential inequality in column A to its correct name found in column B. On your notebook, simply write the letter that corresponds to your answer. 30 seconds will be given for this activity, and that starts now. Time's up. Let us check your answer. Did you match f of x is equal to 6 raised to x to a exponential function? Very good. 2 raised to x plus 2 raised to x plus 3 is greater than or equal to 8 to c exponential inequality? You get it right. What about h of x is equal to 7 raised to x plus 2 minus 1? Nice. That should be matched to a exponential function. What is your answer in 3 raised to x plus 1 is equal to 20? Very good. B, exponential equation. Did you match 3 raised to x is equal to 27 to B, exponential equation? That is great. That's it, grade 11. What is your score? I am happy that you made it to our last activity. Now, let us summarize our lesson for this day. How do we solve problems involving inverse functions? To solve a problem that involves inverse functions, first, you need to determine an inverse function and use it to solve the problem. What real-life situations may be depicted by exponential functions? Growth, decay, and even investment are some of real-life representations that model exponential functions. How do we distinguish an exponential function from an exponential equation and from an exponential inequality? Exponential functions, exponential equations, and exponential inequalities can be distinguished based on their exponents and the symbol being used to represent them. Now, let us proceed to our frequently asked question. First question. Do all functions have an inverse function? The answer is no. The inverse of a function may not necessarily be a function. Second and last question. Why is there a restriction? B is greater than 0 and B is not equal to 1 for the base of an exponential function. First, if b is equal to 1, then we're going to have a constant function, since 1 raised to any real number x is 1. Also, b cannot be 0, since 0 raised to any real number x is either 0 or indeterminate. B cannot be negative as well, because a negative number raised to some particular real number may result to a non-real number. Before we end today's session, let me just remind everyone to answer assessment part of your module. Once again, this has been your general mathematics teacher for today. Saying goodbye for now, stay safe and healthy until our next lesson.